Welcome to Building Sustainability into Your Web Presence. I'm Alex Taylor. I am the Manager of Programs and Digital Experience here at NC Tech. NC Tech is the unifying voice for the tech sector of North Carolina. And if you would like to learn more about NC Tech, as well as any other future virtual workshops coming up, please go to nctech.org. We'd like to thank Umbraco for sponsoring the session today. For some housekeeping items, the session will last 40 to 45 minutes and we'll save some time at the end for questions. If you have any questions, please place them in the Q&A box down below and we'll try to get to them. The session is also being recorded, so I will send a recording out to everyone registered after this, and you can also view the video on our YouTube channel. And then I now want to just pass it along to Filip Bech-Larsen. He's the CTO of Umbraco, and he will be leading the session today. Filip, take it away.
Thank you so much. Glad to be here. Thank you for having me. So building sustainability into your web presence is a talk with a lot of practical takeaways for how to think about sustainability when you're building. So it's basically how to build a carbon efficient website. Today, or even a few years ago, it was estimated that the internet was responsible for almost 4% of global greenhouse emissions, which is about the same as the airline industry combined. So it is a pretty significant thing, and this number is growing. In 2025, it's probably going to be twice as much. So we're seeing a tremendous growth, and there's a lot of unseen carbon that comes from, or carbon emissions that come from the internet. With all of this, it's not simple. There's a lot of trade-off, and there's a lot of things where you think you have it right, and then it's actually the other way around, or something like that. But in this talk, I'll try to make it a little simpler and try to, talk a little bit about some of the principles of what makes a website efficient or not. So the most technical slide is the next one. So bear with me to kind of understand the scope of what we'll be talking about. I'll take you through quickly, what happens when a user actually goes to a website. So it's like the life of a website. So the first thing that happens is, somebody types in a URL into their browser or clicks a link or something. Then there's a local service worker cache. And you'll see this a lot. There's a lot of caching involved in all of this process. And in all of this, you can kind of see what number you can skip to if there's actually a match in the cache. So there's first two levels of caching on the device, where you look up to see if the browser already knows what this page is about. Then you make the request and go to the server. You resolve the DNS, figure out where's this actually at, and then you send off the request to the server. Then there's some server work. So this is everything that happens, on the actual server that runs the website. Typically, there's some kind of server cache, and then there's more work. It leads to the web server. The web server runs the application code, and it probably stores stuff in the memory cache. If not, it'll maybe go to a database, go to some files, go to some external resources to eventually follow and make the response that the user is actually wanting. We send that response back. We're back in the brown land now, which is what the stuff that happens on your device, where we look at where the phone or computer starts to pass the response. What is this? We need to discover what other resources are needed, and then we fetch those in a prioritized order. Then we execute it. There's some headers that have a special meaning. So sometimes you're actually getting back a redirect instead of an actual response. So you have to start over and go to the new URL. But if not, we'll start layouting the elements on the page. So there's a header and a footer and a navigation, and this goes on the right and this goes on the left. And then eventually we'll draw that to the screen. And then we're ready, and we're waiting, and then we're ready to respond to a user event. So a click of a button or somebody typing something in. And a lot of times that leads us to a new request, which starts all of this over again. Of course, for the next one, a lot more might be in the cache, so you might skip some steps. But you see, there's quite a lot of stuff involved here. And just to clarify the colors, so the brown thing is everything that happens on the device of the user. The dark blue is the traffic that goes from your device to the server, and all of the light blue stuff is the stuff that actually happens on the server. So there's a lot of requests when you actually build up a website. So this is how many requests typically are used by content type when you visit a page. So there's images and JavaScript are definitely the most heavy ones. That is a lot of stuff. And I mean, ideally, we would just not use the website. But I mean, of course, that's not going to happen. People needs to go, do their whatever they're there for on the website, and I mean, if you think about it, it's probably better that you actually use the web stuff instead of taking your car and going down to the store, right? You should consider compensating all the emissions that you're responsible for as the owner of the website. If your vendors are not doing that already. So in this talk, we'll look at carbon emissions through energy consumption for the operation, the transfer, and the usage of your website. So this is back to the device and the traffic and the server. But we'll only look at energy consumption. I know there's lots more to it, and water consumption, and minerals, and there's a lot more to it than this. But for the scope of this talk, we'll keep it to just energy because it's easier to measure and it's easier to do something about. And the great thing is, a lot of this actually often aligns with other business goals that you have. A lot of the best practices that I'll share with you are also making your website run faster, which is great for other for lots of other things, typically leading to higher conversion rates of whatever your goal is, whether that's signups or putting stuff in the basket and checking out. So internet carbon usage, it's distributed like this. So there's about a fifth on the server, a fifth in traffic, and more than half of the total is actually on the device. But let's start on the server. So you'll see, as I said during this talk, I have like 25 or 30 hands-on things you can think about. There's a color in the top that says whether we're talking about the server or the client or the traffic. There's a marker on your top right that says whether this is something you should do or shouldn't do. And in the bottom, you see a number that will go up as we go on, so you can kind of follow along how far we are. So the first one is process only once when you can. So that is essentially if you can do stuff, if you're doing stuff over and over again, maybe make a copy of it and keep it ready. That's what we call a cache, right? So put stuff in the cache when you can. Pre-processing may end up worse though. There's a lot of trends these days with your static site generated generators and all of that stuff that's essentially doing a lot of caching, but doing it up front. And that actually might end up worse if you have tens of thousands of pages on your website with lots of edits. You might end up processing a lot of pages that won't be visited until we're actually reprocessing them again. So think about when you actually do the processing, should you do it at publish time, or maybe just do it on the first request of a specific page. Use a content delivery network. This is a great advice also just for speed. The idea of a content delivery network is that instead of having everybody go to your server. There's actually a cache stored in the content delivery network closer to the origin of the user, so that will also save some traffic. But CDN is also a great way to save the amount of compute that happens on your server. Um, and the next one is think about sustainability when you do your architecture. There's a lot of stuff today with should we do headless or not? Should we have a suite? Should we be composable? Maybe you're thinking about microservices or going serverless or backend for front end or and there's tons more here. So like these are all ideas or architectures or how you kind of build your stuff or set up um, your digital experience that you're building. But these have very different influences on the carbon emissions that come from your website. The next one, or I mean, and with this in mind, choose your vendors wisely. Think about what vendors you use. And I promise this is the only time I'll actually put a little bit of Umbraco in the presentation, because that's not really what I'm here to talk about. But when we did the upgrade from classic.NET to .NET Core a few years ago, we saw a huge increase in performance. And of course, better performance leads to you can run the same amount of users on a smaller server, or you can run even more users on the same server, which both of them actually saves energy and leads to less carbon emission. So thinking about what vendors are you using and what's their tech stack doing, how efficient are they actually running? It makes a pretty significant difference. Yeah, so it's just saying that over again. Like a customer of ours saw that when they did the upgrade from older versions of Umbraco to the newer .NET Core versions, there was at least a 50% more performance. Yeah, choosing the right clouds. Carbon net neutrality is really a minimum today. If you look at all the major cloud providers, they're carbon net neutral, meaning they try to go green when they can, and if they don't, or when they can't go green, like if there's no wind or if there's no sun or anything like that, then they typically have a carbon emitting backup, and then they'll offset whatever they actually do that way. And part of that is choosing the right region for your cloud. So typically we're used to picking a region that's closest to us or closest to our users or something like that. But there's actually you have to think about what's actually closest. So this is a quick picture of all the sea cables that actually make the internet work. So of course there's lots of cables over land as well. But just to give you an idea that what might be close in a bird's view kilometers, might not actually be the closest thing if you think about how the cables are actually routing below the surface. And then we talk about gross or net carbon, right? So do we want to be is it all right for us that there's a high emission if it's offset? And maybe I would say that's probably a minimum, but what we would like is there to actually be no emission, or the emission to be very low. So we had there's an example here of a customer moving their cloud work from a Las Vegas data center to an Oregon data center. From a user's perspective, they are pretty close. I don't think anyone will notice the few extra miles or the fewer miles that the speed of light in the cables will actually need to go. But you see that the Oregon region, I think this is Google Cloud, is a lot more green than the Vegas one. So even if your customers might be in Vegas, picking the Oregon one might actually be a better choice from a sustainability standpoint, and your users won't really suffer from it. And another one is thinking about the processing that happens out of process. Maybe you don't have to do that in the middle of the night. I mean, as a software engineer myself, I was trained, and I've always thought that if you have to do like recurring jobs that crawl through a big pile of data, we do it in the middle of the night because there's no customers there. But if it's off process, it doesn't really make any sense. It doesn't really make any difference if there's customers or not. And typically, there's a lot more green energy available during the day because of the sun than there is during the night. So a lot of times it makes sense to actually do this when the sun is shining. All right, so there was a lot of stuff on the server, but let's talk about on the device. So here you see the power consumption on the device actually comes primarily from the antenna. So everything that is network related, so traffic and stuff is part of this. And then from the screen and from the CPU. So the CPU is the processing unit. So this is where all the code actually runs. And of course, here, this is all the processing that happens on device. So you should also really think about sustainability in the front-end architecture and the architecture of your client-side application. There's a lot of talk, 5 years ago or 10 years ago about single-page apps or multi-page apps, and I think that's actually still a thing. Browsers are, making it easier to do better multi-page app experiences, but there's still a tendency to do a lot of single-page app applications, and that might be great. But what we see in terms of traffic and in terms of stuff being downloaded is that for a single-page application, there's typically a larger, startup cost, and then a smaller per page cost after that. Whereas for the multi-page application, that's not as much. So if your typical user only sees one page, maybe building a multi-page application is a lot better from a sustainability standpoint. So this is something you can think about. Think about when you do your when you split your bundles, however you do your front end architecture. There's a significant difference to this as well. And don't forget, as I said, like 60% of the emissions of a website actually comes from the device. So the average website today is actually 2.3 megabytes. And if you look at it on mobile, it has grown more than almost 600% in the last 10 years. And that's pretty crazy because 10 years ago when mobile was started up, there was a lot of just browsing regular websites on mobile phones, and today there's mobile specific websites in a lot of places, and it's crazy that we used to think a lot about building very small and efficient websites so they would run fast even on a small phone back in the day, but these days phone internet connections and phone hardware is so great that we don't really think about it anymore. But that is something we should definitely start thinking about again because it does make a significant difference. If we look at the what that data is actually coming from, here you see that that it is primarily images and JavaScript again. So we saw it before, more or less the same graph with the same stuff on it, where it was, the number of requests, and here it's actually divided into like megabytes or kilobytes, and it's even worse. So images and JavaScript are responsible for so much of the traffic that actually happens. And of course, the greenest request is the one that's never made. So you should really think about overfetching. So there's a lot of architecture patterns today where we're smart about fetching stuff before the user actually needs it. That might be really great, but it also comes with that risk of you fetching more than you actually need. So even if you're smart and split your JavaScript bundles into page-specific ones so that you can be more efficient and load faster. If you then, after the fact, fetch all the other routes, so they'll be in the cache. Maybe that's not really needed until the user actually starts looking at them. There's some interesting projects out there that actually takes a look at your Google Analytics to see what's the probable next page that the user will go to based on your average user, and so you can only preload those maybe instead of preloading everything. With HTTP2, the protocol that powers a lot of the internet today, we had a new feature called push, and everybody was so excited about it. You could actually, instead of having the request go back to the user and then discovering what you needed and then asking again for what you needed, you were actually able to, from the server, send down everything at once because you knew what the user would actually be needing. But the problem with this is that there's a huge risk again here for overfetching because you don't know what they already have, what the user already have in their cache. So if you're just sending stuff down people's throats that they don't really need, it's not really a great fit. So I would say you should probably avoid H2 push and do it in a different way with some smart preloading strategies instead. Or if you have to use it, you have to have a really good reason and be very much aware of the potential downsides here. Of course, redirects are extra traffic. There's a sometimes you do you get a new website or anything like that, and you need to have a redirect from one former URL to the next one, and that means that your server will know all the redirects that are out there. And like what the old URL was and what the new URL is. And a lot of times we do traditional 301 redirects where we actually tell the browser that this is not what you're looking for, it's actually over here. And then we send back a response that's basically empty with just a new URL in it and the browser needs to start all over during that process I showed in the beginning to get everything from the server from the new URL. So instead of that, a lot of times you can actually just send the content along with the request with the old URL, so the user doesn't have to do another round trip to get the content that they're actually looking for. And if you're thinking about how does this affect my SEO and stuff, with a small link tag, canonical link tag on your page, you can actually tell Google that this is not the URL you should be indexing. This is the old one. This is the new one that you should be indexing. So you get the best of both worlds that way. The redirect that you shouldn't do, of course, is that you shouldn't avoid, of course, is the redirect from HTTP to HTTPS, so that there's actually an encrypted connection between the user and the server. But instead of doing that the old-fashioned way with HSTS, there's actually a way for you to sign up to the like letting the browser know that this website only works with HTTPS, so you don't need to try without. You can just automatically do the redirect in the browser, and that is definitely something you should look into for all the domains that you have. Then there's minimize the number of host names that your website actually requires. It used to be a best practice to have separate host names for like images or for assets or something like that. It used to be a workaround because the browser could only fetch a certain number of items in parallel from each host name, and so it was kind of a workaround for that. But that limit is no longer there if you're using HTTP2, and you should. So that means what used to be a best practice is actually a worst practice now, because there is some amount of extra work needed for the browser to look up the host name to figure out, okay, what server is this coming from when there's a different host name on the URL. You can self-host your fonts, your tracking scripts, all of that stuff. If that's possible, there might be some legalities in terms of licensed fonts and stuff where you need to actually host it on a specific region. But if you can't, if there isn't, then you should actually host them yourself. Like if you're using something like Google Fonts or something like that, download the files, put them on your own server, so we don't need to ask and figure out where that specific Google server is that hosts those things. But you can just send them from your own. WebSockets is also a thing that some people think about when they think about optimizing the data requests, and it's kind of the same thing as the multi-page versus single-page thing that we talked about before, where you might save something on the data that goes through a WebSocket when it's actually set up, but the setup work is significant. So again, you probably shouldn't do this as an optimization for that at least. And then we're back to utilize on-device caching. So I showed off the very first thing the browser does is to see if there's already a copy in the service worker cache, and that's because the service worker is a cache that is persistent, so you can actually count on it being there, and it is something where you can control everything yourself. So it's basically a programmatic, almost like a proxy where you can. Whenever a request comes in, you get to decide whether we actually should ask the server or whether you already have something in store that you can just serve instead. Of course, the big negative here is you have to control everything yourself. So there's a lot of work in that, and probably not something you should just try to think about and do all of the work yourself. But if you go to the link that's on the slide here, of course, I'll share all of the slides afterwards. If you go to that link, there's actually a great project from Google that's an open source project that lets you do all of this in a very efficient and easy way to manage. That's a lot like how you do routing in Node.js, if you know that. So the next thing I want to say is that you should probably be using the lazy loading attribute or the loading equal lazy attribute on most of the things. It shouldn't really say all of the things because it might slow down your very first or your big hero image if you put loading lazy on it. But everything that's not what you would call above the fold, you should definitely put loading equals lazy on it. So this is of course images, it is videos, but also like external iframes or anything like that. If you put this attribute on it, it won't load until the user is actually scrolling down and is getting close to it. So there's a lot of traffic to be saved if you put this tiny little thing on, and of course it means that the website will also be available faster for the user because we don't need to wait for stuff to be downloaded before you need it. Yeah, I think I talked about smart lazy loading before as something you could look into. For all of this, the idea is that smaller is better. So the best request is the one that's never made. The second best one is the one that's really small, or only as big as you really need to. A really great way to do this that's very often overlooked is the ability to subset a custom font. So a lot of us have custom font for our corporate identity or something like that. We need to look just right. But if you look at a font like I think this is one of the Google fonts. I don't remember what font it is, but you see there's like 5 different A's, and at least in our alphabets, we very rarely write any of those other A's except for the first one. But that still means that if you download this font, or if you tell your user to, or your browser to use this font, it will actually download all of the letters and have them available for you. But there's techniques where you can pull out all of those, put them into a separate file, so you'll only load them when they're actually needed. So you can have a much smaller font up front that'll probably be enough for 99% of your pages. Minifying your text assets is also something you should look into. So we've had gzip and Broadly and protocols that actually do this very transparent for you, so you don't even have to think about it. In most servers, it's just a setting you turn on. In most servers, thankfully, it's turned on by default. But when we look at the data, there's still around 25% of all web traffic that's still not minified like that or compressed like that. Yeah. So this is really that thing as well. You should think about how you scale your images. So if you have a user using a phone, maybe you don't need to send down a very huge image because it's going to be shown on a 2-inch device anyway. And the same for your desktop websites. Really, what's the actual size that is needed? Make sure that you don't send more pixels down that you actually need. And talking about the pixels that you then do need to send, you should absolutely be compressing your images as well. There's a lot of images again being served completely uncompressed, and that's just a lot of extra traffic that no one gets any benefit from. So if you go to squish.app, there's a really good tool where you can upload an image, and then you can play with like different compression settings and different compression algorithms and different formats, and see how low you can actually get it. And if you look at this image in particular, you've seen that we've actually saved more than 69% of the original image size, and I'm sure that you won't be able to tell the difference. So this is just, you know, compressing and choosing the right quality in your compression. GIFs are fun. You know, we've always had, or at least for many years, we've had great GIFs that you know, brings a lot of joy to the web and to presentations everywhere. But you absolutely shouldn't use actual GIFs. You should encode these as videos instead. That is so much more efficient in terms of what you get. You get a lot higher quality for the same byte, or you know, a lot less bytes for the same quality. Please turn off autoplay anywhere you have it turned on. Not only is it what I think is a terrible UX when actually videos start playing, especially if there's audio in it without me clicking something first, but it's also very, very wasteful. There's just a lot of data that's actually needed to play a video, for instance, that your user might not even want. So I tried to make an example of what this actually converts to in practice. So here's a 20-second YouTube clip. So if I just put it in like you would normally do, and push autoplay on it, it is 7,000 kilobytes. So this is 7 megabytes. So this is, you know, almost 3 times the size of the average website just for that 20-second video. If we do the embed, but turn off autoplay, immediately we go down to 250 kilobytes instead. So a significant difference. Of course, this means that, you know, if the user then actually clicks the play button, they'll get the full 7 megabytes. But that's all right. If there's actual value in it for the user, of course they should watch the video. But if there's no value, there's a lot of data to be saved right there. And even better, maybe, you know, put an image in there, and maybe put a play button or something that looks like a play button on top of the image, and because the embed itself from YouTube is actually pretty heavy in terms of data, so you can actually take that down further than 90% and go down to 25 kilobytes if you want to have that on-demand embed instead. And the user probably wouldn't know. Maybe the load time when you click the play button is a few 100 milliseconds longer, but I think most people will survive that. And maybe there's a UX trade-off somewhere if you want to have somewhere in between, where you maybe have a super small video that is very compressed, that autoplays, and then when the user clicks that's actually when you do the YouTube embed. So you might be able to do stuff like that and pull it off and get 90% or 95% of that user experience that you want for a lot less data. And what does that actually mean? So I tried to do some math here. So these are the, like, if you go to the links, you can see how I'm calculating this. But the point is, even if 1 out of 10 actually click the button and still watches the entire video, from every user, we can actually save 1.67 grams of CO2 for every visit. So that means that a flight from Copenhagen, where I live, to Stockholm, or from Charlotte to Chicago or something like that, it's only like you can actually make that up in 40,000 visits, and a lot of us may have 40,000 visits. Some of us may have it on our websites every day. For some, it's maybe every month or every year. But I'm thinking most of us will react to 40,000 visitors as something that's not completely crazy. And we can actually save the equivalent of you know, me flying somewhere. I think that's pretty significant just from that UX trade-off of, you know, putting an image with a play button instead of actually using the auto-playing video. The last couple of ones are about the screen before we hand it over to questions. But a huge one here is dark modes. So you saw that 60% of the emissions come from the device, and of that, the screen next to the antenna, the screen is the biggest sinner, if you wish, in that. And modern screens today are mostly OLED on your phone or on your tablets, or if you have a modern laptop. OLED displays are use significantly less energy when they're showing dark pixels than when they're showing light pixels. So a lot of us already built dark mode into our websites because it's a great user experience. But most of the time, until the user actually changes what they want, we start out with the white mode or with the light mode, and just by swapping that around, you're actually doing a pretty significant difference. I think we were looking at an immediate power savings of more than 50% from just turning to dark mode. Huge difference. Yeah, up to 47%. And then that leaves us with the processing on the device as the last thing to cover. And again, here, the greenest processing is the one that never happens. So do it once, put it in a cache is a great way to think about it, right? But the other one is doing efficient animations. Like, we all love animations, and how an animation works today is that, all the code builds up, the HTML turns into a DOM tree, all the CSS stuff it turns into what's essentially a CSS tree. We blend those together and we build a render tree. Then we do layout, which actually sets out where everything is, and then we actually paint it to the DOM, or paint it to the screen. And when you're doing an animation, if you can think about not having to do all of this for every frame, there's a lot of work to be saved. So if you're doing an animation with CSS, if you choose to only animate the things that actually happen on the GPU, so like doing CSS transforms, scaling and opacity, doing stuff like that, is actually all on the GPU. So we would only have the last thing actually happening over and over again every frame, instead of doing all of it every frame. And a lot of times you can be smart if you think a little bit about it. Instead of animating the distance from the left, just translate the element to the right instead, or doing something like that. You can get the exact same user experience in a lot more efficient way, and it'll also be smoother on the device. The user will have a better experience, so everybody wins. Putting things in perspective, there's a lot of stuff you can do here. I'm sure most people will think, I can do at least one of these. I can go home and do tomorrow, and that's kind of the point here. Of course, doing one of these are not going to save the entire planet, and there's probably other things to consider in your business as well. But these are things that we as developers, that we as tech people can actually do, that does make a difference. And it's one of those things where one thing might not change the world, but if we all do, we can actually make a pretty big difference. Ending up with just one tool of how we're doing here. There's if you're a web developer yourself, or if you know people, they will definitely use the dev tools that comes inside of the browsers. And in most of these, there's actually now open source sustainability plugins that you can put in that will analyze your score, just like you're used to from Lighthouse, that gives you a performance score and an accessibility score, where you can actually also get a sustainability score, whether your servers are running on green electricity, how much power or how much traffic is actually needed for your website, and stuff like this, with lots of great stuff to work on. And if you want to try it out, there's a admittedly pretty naive but still useful website. It's called websitecarbon.com, where you type in your URL and you'll be able to see how you're doing compared to other websites, how much traffic how much CO2 a visit to your website will cost. Yeah, so you get a response, something like this. So the last thing is, shouldn't we just all use an app instead of a web? And I guess this is basically back to the same trade-off as the multi-page versus single-page one. If for apps, app sizes today are huge compared to websites. So if your user only uses your platform very rarely, or something like that, you should absolutely just do a website instead, because where an average website, it was 2.5 megabytes, an average app is like uh, 30 on Android, and I think it's like close to 100 on iOS. So there's a significant amount of data being transferred to actually get your app running. So a lot of times, maybe it could just be a website instead. We can do stuff by making good decisions. You're not alone. We're in this together. There's a great website called climateaction.tech, which has a community that cares a lot about sustainability, and they'll help you. There's a Slack channel and a community discourse and stuff where there's a lot of talks, and this is a great place to get advice on how do I do this better or how do I do that better. And with that, I think we'll take it over to questions. There's a QR code here where you can download the slides if you want to. Otherwise, I'll send them out as well. So you have them. But let's see if we have any questions.
Thanks, Philip. That was awesome. A lot of great takeaways from that presentation. But yeah, as Philip said, if you have any questions, please place them down in the Q&A function at the bottom of your screen, or it might be the top. So we'll wait a couple of seconds to see if any questions come in.
So for those of you who try the website Carbon Calculator and put in umbraco.com, you'll see that we're not doing very well ourselves right now. We are working on that. It's a lot of fun. Sometimes you can't wait for the world to be perfect in your end before you start trying to change the rest of the world. But I'm painfully aware.
Yes, I want to run NC Tech's website through that as well and just see now. Yeah. We do have one question from Jen. Do you have any advice for the best options for sustainable hosting solutions?
I mean, all of the major cloud providers today, they actually give out data on each specific region. So if you go to Azure or you go to Google, to GCP or to AWS or something like that, you can look up, how much of the power is actually green or where is it coming from. And at the end of the day, you should be fine with if you choose one of the major ones. Of course, yeah, as I was saying, think about choosing the region that's closer to your user, but not at the cost of what's the most efficient one, right? Yeah, so I don't think you'll be too bad off if you choose any of the main ones. But think about it. There's an open source project, I don't remember the name right now, but that does dashboards for you, so you can actually plug in all of your even if you have multi-cloud set up, you can actually plug in all of your accounts, and it'll see how much from each resource is actually emitted, and turn that into actual grams of CO2. And of course, I mean, the point of that is so you can follow along. Of course, it's great to be at a great place, but what you really want is to set something up where maybe part of your build pipeline is trying out a test like this, so you can find regressions if you make one, and roll them back or fix them before they make a bad difference.
All right. Are there any more questions before we end this session? Wait a couple more seconds. All right. Well, thanks again, Philip, for leading this presentation. That was awesome. As Philip mentioned, we will send the slides afterwards, as well as the recording to everyone that registered. And if you would like to learn more about NC Tech or upcoming virtual workshops like this one, go to nctech.org. And then thanks to Umbraco for sponsoring this virtual session. But with that, I will end this session. Everyone have a great day.